Hello, this is Paul from Foresight Tech. In this lecture, we are going back to the problem of slope, the slope problem we discussed before. And we were focusing on the calculation by using, by evaluating the limit directly. What is slope of the tangent line? As we discussed at the beginning of chapter 2, we can do what? We can use the slope of the secant line and then take a limit. Then we're going to find the slope of the tangent line, right? And for the slope of the secant line, we have two forms. So the first or the second, we look at the graph. We just go over a little. If we have a curve, then we have a point. How to find the slope of this tangent line? We can do another. We find another point Q. We link a PQ together. This we call the secant line, right? Find the slope of the secant line, and then take a limit. What the limit? We pick a Q approach P, which means we take a X approach A, and this is graph. So what is the slope of the secant line? Slope of PQ, which is delta y, right, over delta x. So this time delta y is fx minus fa, which is the numerator. Delta x is x minus a, which is the denominator. And then this is the slope of the secant line. Take a limit, we get m. Okay, later we're going to do evaluation. Evaluate this limit, we can find the slope of the tangent line, and then we can find the tangent line equation. The second case is the same. Okay, if we say PQ is not use the x coordinate, is not use x, but they use what? Use a plus h. H is the increment in x-axis. Okay, which means the distance between these two on the x-axis. So that's delta x, right? Was delta y? Delta y is this time is fa plus, which means how high this fa plus h minus fa. Okay, the distance between y, which means delta y, and this delta x. And then this time the limit, what do we need to do? We need to take h approach 0. H is delta x. Okay, the increment on x. The two forms are exactly the same, but which one is the most popular? Okay, so the second one, usually we would do calculation using the second formula to find the slope. Now let's do calculation directly. We're going to find the slope using the second form of definition. We'll look at these questions. Find the equation of tangent line to this curve at this point. Okay, that point, which means what? X equals 2. Okay, which means a equals 2. This time a equals 2. We need to find what? We need to find the slope of the tangent line first, and then take a limit the slope of the tangent line, and then we find the line equation. And let's follow the definition. So here is y, which means f, right? So we can do what? Let me write this y into f. So we can do this. We can let fx equals y, which is x squared minus 3x plus 1. Okay, and then we are going to use the definition. What is the definition for the slope? Which is m is the slope of the tangent line equals the limit. I use the second definition, which is h approaches 0, right? Okay, and then the definition is this. Delta y is f at x plus h minus f at x. See, this is delta y. Of course, so here is a equals 2, right? So what do we need to do? I have to change this to 2. Okay. Change this to 2. So I have to change this to 2. Okay. Because here tell us a equals 2. Okay. So we need to evaluate this delta y. So what is delta x? Is the difference. This is h. Okay, that's the definition. And then we're going to evaluate this as we did before. We have a lot of scales, right? Okay, now I just evaluate f, plug this f function to here, and then see what I find is the limit h approaches 0. Okay, a little bit longer. So h is still here, and the plug this f is there, which means 2 plus h squared, right? Minus 3x is 2 plus h. So that's 2 plus h and plus 1. If you like, we can put a bracket here. This is f2 plus h minus f2. Okay, f2 we're going to evaluate with directly find is -1. Okay, f2 is -1. Okay, so this is the one. Then now we need to simplify the numerator. Okay, how to simplify it? Let me write down all the details. A little bit longer. The bottom is DRH. So now I have to this is the perfect square, right? Spend the perfect square, which is 4a squared plus 2ab is 4h plus the second square, h squared. The minus distributor, minus 6 minus 3h plus 1 and plus 1 more again. Okay, so we're going to simplify. See what do we get? So we simplify, we are h squared, right? And the plus h, and then is 4 plus 1 plus 1 minus 6 is 0. Therefore, I wrote it down here. Another page. What do we find? We exactly find this, and we find that the limit h approaches 0. Okay, we have h squared left, and there were 1h left. Okay, and h, and this is just a simplify. Or we say it's a compound-like term. After you simplify, we get this. Okay, and then what do? We can do simple. Now it's just a simple evaluation. We factor the h, so we have h plus 1 over h, right? So this is just factored out h, and then what to do? And then we divided out the h, right? And then we divided out h. Let me see. And then this h and this h can cancel. See what do we get? So we almost we get the limit h approaches 0, right? And h plus 1, and this limit of course equals 1. So we find the limit, and then what to do? Find the tangent line. This is the slope. We can use the point slope because we know the point, and then point slope can give us the tangent line equation. So what do we have? So we can find the tangent line equation. This is what we need. Is this? Okay. The point slope. Let me write down this name. Remember, point slope, because we know the point, we know the slope is 1 now. Okay, the equation of the line is y minus y0, which is f2, right? And then should be equals slope m times x minus x0. This time is 2. Is f2. This is 2, and then plug. What is f2? If we go back to this is not equals, so minus -1. Okay, -1 f2. What's the m? We find it's 1 plug. So here, and then x minus 2. Of course, now it's easy, right? We simplify. All we need is just simplify. Simplify, we get this equation. Looks much simple. Y equals, this is we plus -1 both sides, so -2 plus -1, which is -3, so equals x minus 3. So this is the result, and that's all. Thank you.